Hello, how's it going? Hopefully you're having a good one. Good morning, good afternoon, good night. I don't know what time you're watching this, but for me right now it's 1 a.m. This is the only time I have to work on this. It's what happens when you have two kids under 2 years old or under 3 years old. In any case, this is a sample for response question for the AP Computer Science A exam. This is again a problem that you'd have to answer with pencil and paper. You would not have access to a computer, but I figure I want to help you prepare for the AP exam, and I want to clarify any questions. I do recommend that you try to code this before you watch the entirety of this video, so that you give yourself a chance to try to work through the problem. And then if you require maybe some clarification or some direction, then you can look at the video and take a look. This video is only meant to help. Trying to memorize how to work these out is going to be impossible. Clearly, you're not going to have the same exact problems on the AP exam when you take the AP exam. So look through it and just understand that this is just merely meant to clarify, to help you work these problems out. Here's the problem. I call this code SkyView because the class right here is public class SkyView. Basically what happens, and they're trying to give you basically a sense of what's happening. This is supposed to be data collected by a telescope. These values 0.3, 0.7, 0.8. And the telescope is basically scanning the sky from left to right and back and forth. So it's scanning, and that's why these arrows are supposed to signify. So you scan the sky as the telescope moves to the right. It's scanning. Once it reaches the end there, it turns back and keeps scanning towards the left. And then it reaches the end and keeps scanning back, so on and so forth. This is a good example of a problem where a two-dimensional array might be useful. And that's why I have classified this FRQ. Well, actually, I have not classified it. College Board classified it for us as a two-dimensional array FRQ problem. Here's something important. The telescope records the data in a one-dimensional array of doubles. And then this one-dimensional array of information received from a single scan will be transferred into a two-dimensional array, which reconstructs the original view of the rectangular area of the sky. Now, that is actually going to be your job. Your job is going to be to take a one-dimensional array, retrieve all that data, and put it, assign it to elements within a two-dimensional array. This is the skeleton here of the class, SkyView. It has a field called view, or an instance variable. It is a two-dimensional array of doubles. There is also a method called constructor. It's not a method. The reason I know this is a constructor is because it has the same name as the class, SkyView. Case and all, meaning the same uppercase, lowercase letters. And it does not return anything. It omits the word void or any data type. So it is declared as public. There are three parameters: an integer called numRows, another integer called numCalls, and then an array called scanned. An array is a one-dimensional array of doubles. So three parameters. This is what we're going to be implementing in part A. I'm going to try to keep this video short. It's already late, and so I'll probably create a new video to implement part B. Okay, let's look at part A. By the way, the method that we are to implement in part B is called getAverage. It returns a double, and it requires 4 parameters, or 4 arguments, because you have 4 parameters here: start row, end row, start call, and end call. Write a constructor for the SkyView class. The constructor initializes the view instance variable two-dimensional array numRows and numCalls. Okay, there's a lot going on here, but basically, this constructor SkyView is supposed to populate. It's meant to populate the two-dimensional array view. It's supposed to store values in view. The information from scanned, which is stored in the telescope order, is copied into the view to reconstruct the SkyView originally seen on the telescope. Okay, this is an example here. Suppose that the constructor, SkyView, receives this one-dimensional array. The name of the array is called scan. So it has this data 0.3, 0.7, 0.8, and it's in a one-dimensional array. So there's just one row of numbers here. In this case, there's 12 elements. Remember that indexing starts at 0, ends at 11, so there must be 12. And your constructor is supposed to do the following. It's supposed to take all this data and populate the two-dimensional array called view with that data. Now, it's going to do it in such a way so that when you start with 0.3, that's the first element, 0.7 is the next element, 0.8 is the next element, and when you reach the end of the first row, the rows, by the way, are horizontally, and there's 4 rows. The columns run vertically up and down, and there's 3. When we reach the end of the first row at 0.8, you snake back down. It's actually called like a snake. Snake back down, and the next element, 0.4, is going to be stored right below it. And then you keep going to the left. So 1.4 is the next element, and then 1.1. And then you reach the beginning of the second row, and then you snake down and store the next element, 0.2 right here, 0.5, so on and so forth. And that's the job. Now, 4 and 3, notice right here I have the heading here, SkyView 4.3, and then scanned. 4 is the number of rows. There's 1, 2, 3, 4 horizontal rows. 3 is the number of columns. There's 1, 2, 3 vertical columns. And that's the sole purpose of the constructor. So this constructor is supposed to take care of some business here. Okay, I've pre-written these. I'm using JGrasp, SkyView right here. So I just kind of copied what they had here. And this is going to be the tester class with the main method. This is the one in charge, basically. You run this class and it tests the SkyView class. Alrighty, I had to pause there for a minute. Okay, so all the code for part A is going to be implemented right here. It actually has a comment there. It says to be implemented in part A. And so that's what we're going to be looking in this video. I think part B, which is this right here, I'm going to just copy this, Control C, and then to paste, Control V as in Victor, and B right here. It's late at night right now, so I'll probably won't get to this today. I'll just record another video for it. I'm going to do it as I would do it. There might be some mistakes. I haven't coded this before. But again, already you can see I have an error here. I'm supposed to return a double. That means there needs to be a return statement. To get rid of that error momentarily, I could just return 0.0. Control B compiles. So I compiled just to verify all this is good. I was saying that I have not coded this before, so this is a free response question that I'm coding for the first time. And so I'm going to code it as if, well, I'm going to code it and with the understanding that I might get it wrong. But that's the whole point. The whole point, especially when you're practicing for the AP exam, is to try something. And if you're not successful, then debug your code, understand what is not happening, whether it's a syntax issue, maybe you forgot a semicolon, maybe you didn't initialize a variable, or whether it's something to do with the functionality of your code. Maybe it's not working. It's working. You're compiling, and your code runs fine, but it's not giving you what you're expecting. And so that's, in my opinion, the best way to learn how to program. To just code, and if you get it wrong, try to figure out why it's wrong. Okay, so num rows. It's supposed to give you the number of rows. Numcols is supposed to give you the number of columns. And so you notice here view is a two-dimensional array. Usually when you make an array, you would say, okay, it's an array, a two-dimensional array. There's 2 sets of square brackets. That's how you know it's two-dimensional. It has doubles. Doubles are values that can store a decimal value, and you would typically say equals new double, and then you specify the number of rows 4 and the number of columns 3. Now the reason I don't want to do this right here is because I'm not always going to have 4 rows and 3 columns, and so hard coding the 4 and the 3 here would mean that every time that you make an object from the SkyView class, this two-dimensional array will have 4 rows and 3 columns. Now, yes, you can overwrite that, but the point is to not do this. So I'm going to actually cut this, Control X, because I'm going to come down here, and the first thing I want to do is I'm going to specify the size of view. How many rows and columns does it have? 4 and 3. Now, again, I don't want to hard code. That means like actually put the number 4 here, or hard code the number 3 here, because it's not always going to be the case that I'm going to have 4 rows and columns. What I am going to do is I'm going to use this parameter, num rows. It's going to store the number of rows that I want. So somebody might send the number 4, so we'll have 4 rows, and then the number 3, and that's going to have 3 columns. So I'm going to copy this, double click it, highlights the whole thing, Control C, and then Control V will paste. I'm going to copy the num calls, and there I have it. I'm going to compile to verify that I have no issues. Okay, so now I've specified the size right here. This is specifies, or I'll just put here, size is num rows by num calls. Okay, that only specifies the size of the two-dimensional array, but it doesn't assign any value. There's nothing in it, basically. And that's our job. Our job is to take this one-dimensional array and store every number within the two-dimensional array. Okay, let's see here. When you're trying to access or store values in a two-dimensional array, in this case we want to store some numbers, the nature of this is very repetitive. For example, if I want to store a number at the first location, 0, 0, and let me show you what I mean by that. That would be row 0, column 0. I want to store the number 0.3. I could do it like this. View of 0, 0 equals 0.3. And then I can do, okay, view and then row 0, column 1 equals row 0, column 1, that's 0.7. So I would put 0.7. And you can continue view 0, 2, that's row 0, column 2. So I go here, row 0, column 2, 0.8. Now this gets the job done, but there's two things that are probably that's not good, that are happening that are not good. One is we're gonna have too many lines of code. It's just, I mean, imagine if you had 100 rows by 100 columns. It'd be ridiculous, you know? It'd be 100 times 100, that amount of lines of code. So we don't want to do it this way. You also are tying your hands. You're saying, okay, I only have 3 columns, 0, 1, 2, and 3 on the first row and the 0th row. But again, we don't know that. We don't know if the number of rows and number of columns. They're variables for a reason, because the user who's testing or who's using this code is going to specify that. So that's the other thing, hard coding. So one is the number of lines, and then the other two is that we're hard coding. We're making assumptions. Now, what is true is that there's a lot of repetition going on here. Specifically, the view 0, 0, view 0, 1, view 0, 2. That repeats itself. Equals is also repeated. And the only thing that's changing here is this value. So when we want to traverse a two-dimensional array, we use a nested for loop. We say we're going to use a for loop, int row. We're going to start the row at 0. We want to go into rows less than the length of view, Or for this specific example, we can do view.length. That gives us the number of rows in the two-dimensional array. You have two options. You can do view.length, or you can just do rows less than num rows, because num rows is specifying how many rows it's going to have. So it's up to you. I'm actually going to go the other route because I want you to feel comfortable with this. When you have a two-dimensional array like view, get its length, it gives you the number of rows. And then a nested for loop is basically a for loop within a for loop. So we have an inner for loop, for int call. We'll start that at 0. We want to go until call is less than the length of the ith row, or I don't want to call it ith row. I want to put 0 here and I'll change it in a minute. But if I look at view and I only use one index, so 0 instead of like 0, 0. If I look at just one index right here, so that means I omit this, I delete it. Then I'm saying let's look at the first row, the 0th row, or the 0th element in view, and get its length. I forgot the L. There you go. And so this right here is saying, okay, give me the length of the 0th row, which basically gives you the number of columns. 0 might not be the best thing to do here. Instead, we could use row. Row is going to be changing, so instead I can put here row. And then I'm going to increase columns by 1. Now here is where I would say view, and I would put here row call equals. Now understand that the way a nested for loop works is that you're gonna iterate through the inner for loop. That means call is gonna be 0, and then call is gonna be 1 and 2 and 3 until this criteria is no longer true. And once you've finished iterating through the inner for loop, you cede control to the outer for loop. And so you would go back, you'd be done with the inner for loop, go down to this curly brace, which then loops back, and then you look at row, you increment row by 1, and so row is now 1, and you loop as many times again, and then you increment row by to 2, and you loop, and you increment row to 3. And so basically you're going to fill the entire first row, because this is going to be 0, while row is 0, call is going to be 0, 1, 2, 3, however many columns there are. And then while row is 1, call is going to be 0, 1, 2, 3, however many columns there are, and so on and so forth. Now I know that I want to do something like this right here. View of row call is scanned, which is a one-dimensional array of, I'm going to make a new variable here called I. And I'm going to say that I here, I need to specify its data type, int I is 0. And then I'm going to say I plus plus. Now what this is going to do, this is actually, I know already that this is not going to work the way I want it to work, but that's not necessarily a bad thing. I'm going to say row of 0, 0 is scanned of 0. And then I increment I by 1. And then row of 0, 1 is scanned of 1. And then row of 0, 2 is scanned 2. Because I'm adding here 2. Every time I'm incrementing I by 1. Alrighty, that was the baby tossing and turning. Now I'm going to test this. So let me go to this tester class. I need to code this array. It's an array of doubles. I'm I don't have to call it scanned. I'm actually not going to call it scanned because I want to make sure that there's no confusion between the naming convention here. And I'm going to hard code these values. And so I'm going to do 0.3, 0.7, 0.8, 0.4, 1.4, 1.1, 0.2. Let me move this a little this way, and then, oh, there it is, 0.5, 0.1. Let me actually move this down. There we go. 1.6, 0.6, and 0.9. I need a semicolon. And then I'm going to compile to verify I have no issues. The compilation is good. Now let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's good. I didn't miss any. Now, this is how we test. We were in this SkyView tester class. It's a separate class. They're both saved in the same folder. They need to be. If not, they won't be able to find each other. I'll go to the end here. I actually don't need to do this. I can make this as big as I need to. Okay, we're going to instantiate an object of the SkyView class. Which is key. This is the whole point behind Java. It is object-oriented programming, which means you can use the SkyView class, this class, and make as many objects as you want from this class and basically have access to the code that we have in here. We're going to create an object by specifying the object that we're creating. It's a SkyView class. I'll call it view. Maybe view is not a good name because that's the name for this this field. So maybe not view. We'll call it like summer night. You know, it's the data for a nice summer night here in Imperial. Nice. That's debatable. Now we use the Constructor New Sky View, and this is where we specify the number of rows, number of columns, and we send it the one-dimensional array. Right here we call them arguments. So the first argument is the number of rows. I want 4 rows. The second argument is the number of columns. I want 3 columns. The third argument is a one-dimensional array of doubles. That's all specified right here. First argument, they're called parameters here. First parameter, second parameter, third parameter. And this last parameter is an array of doubles. The square brackets say that we need an array, which is basically where when you store more than one double in one variable. And so we already have an array of doubles. It's called S. Now the reason I didn't call it scanned is because I want you to understand that this variable S exists in here in the SkyView tester, and it contains these elements, all these. And when I send this array S to the SkyView constructor, it's going to be stored locally in this variable called scanned. And so I don't want to give them the same name. It wouldn't make a difference if I called this scanned and then sent scanned, or if I call this X and I send X. So it makes no difference. I'll just go back to this. Now what's true is that I need to see if I stored the numbers correctly. And let me save this. As a matter of fact, let me compile to see if there's any errors. That's good, there's none. Now, you see how view right here is where I'm storing view equals. I'm storing the values in scanned into view. View is a private variable, which means I don't have access to this variable from outside of this class. So I do have to write a getter method. A getter method, or more formally known as an accessor method, lets you access the fields, the private fields. So I'm going to say here, I'm going to make a getter method public. They're called getter because they're usually given the name get. Public, I want to return view, so that's an array of doubles. I specify the data type of what I'm returning. Get view. There's no parameters because I don't need to send anything to get view. All it does, and I'm going to write it in one line here. I could put it in the next line, but because it's just a simple one line of code, I'm just going to put here return view and then terminate with the semicolon. I could put it like this, and if you feel more comfortable doing it like this, by all means, go for it. But I try to save myself lines of code, and this gets way too populated, so I'm just gonna go back to how I had it, like that. So the Getview method returns to you the two-dimensional array view right there. And so right here, I'm going to compile this. The array is a two-dimensional array, so I need another set of square brackets. I'm going to compile. That's good. Notice how this right here matches this, which it should, because I'm returning view, and view is a two-dimensional array. I'm going to go to my tester class. I'm going to say, hey, from summer night, which is an object of the SkyView, a SkyView object, let's execute this Getview method. Now, when I run this code, I'm going to get back the two-dimensional array, which means I need to store it somewhere here. So I'm going to make a two-dimensional array of doubles called results equals what Getview returns to me. And then I'm going to do a quick for loop, a for each loop, for each array of doubles row in results, and then for each double x in row, let's print. And I'm going to do a formatted printing because I want these to be spaced. Actually, you know what? They're all just 2 digits, so I think I can get away with it. I just want them to look nice when I print them. I can get away with just the system.out.print. I don't want to print in a new line, so I don't include the ln because I want these side by side. Print x followed by just a space between the values, and after I print all the numbers, all the x values in the first row, I want to print a new line. And I'm going to compile, and I'm going to run. And you'll notice that this is actually not what we want. Let me show you. It doesn't match. The first row is good, 0.3, 0.7, 0.8. But then the next row was not stored as I wanted it to be. I stored the 0.4 at the beginning of the row rather than at the end of the row. So that's not quite working out for me, which means I need to make some changes, but that's not a bad thing. Okay, so let me think here a minute. This is going to be 0, 0, and then 0, 1, and then 0, 2. And then I'll be done with the looping here. So I'll go back, and row is going to be incremented by 1. So this is going to be 1, 0, because column starts at 0 again. And then 1, 1, and then 1, 2. And that's not what I want. I want this to be 0, 1, 0, 0, 0, 0, 1, 0, 2, and then when I go to row 1, I want to start at 1, and then the last column, which would be 2, and then 1, 1, and then 1, 0. Which means I want my column to be decreasing. Okay, so let's see here. This is what I'm thinking. I'm thinking I'm gonna leave this for loop. I'm gonna leave it as is because I do want row to start at 0. I want to increment row by 1, and I want to go into rows less than the length of view, which is 4. There's 4 elements, 4 rows, so I want to go into rows 3, which is the last value here, 3, third row. So that's fine. The issue is with this for loop right here, because I don't want the column to always start at 0. I want, when I get to the second row, or which would be row 1, I want call to start at the end, not at the beginning. So I'm thinking here, and I'm going to try it. I don't know if it's going to work, but that's, again, the whole point. I'm going to use a while loop here. While rows, not row, while call is less than, I'm actually just going to use num calls. While the column number is less than num calls, assign here, we do need to, because we don't have the call plus plus anymore. This is what takes care of increasing the value of row. In the while loop, you need to increase the column number within the loop. So I'm going to say call plus plus, like that. So that would be, for example, 0, 1. I'm sorry, 0, 0. I actually need to initialize the column number now. Let me initialize it up here. Int call equals 0. So call is 0. 0 is less than the number of columns, which is 3. That number is 3. 0 is less than 3. So view of 0, 0 is scanned of 0. And then we add 1 to I, and we add 1 to call. And so then 1 is less than 3 still. So that would be 0, 1. And that would be 1. I believe this is going to work the exact same way as it was working before. So I don't think I fixed it yet, but I want to try it out. Actually, it didn't work. You see, I only populated the first row. Oh, that's because I kept increasing column regardless. It's odd that I didn't get an index out of bounds exception. I'm going to say that if call is equal to 3, that means I've already stored the last value, because that would be 0, 2. So row 0, column 2, and then I increment column by 1, so now column is 3. If column is equal to num 3, I want to restart call to 0, so that I go back to the first column. Let me compile, and I think this should work as it used to work. No, I got an index out of bounds exception. That's odd that I didn't get that before. Okay, I see what happened here. This is actually taking care of call never being 3. Call is never going to be 3. Num calls is 3. What I need to do is I need to have this right here. Control X. I need to have it in here so that after I'm done populating a row, I initialize column again to 0, and I can get rid of this if statement. All right, let's try one more time. I'm going to compile, and then I didn't make changes here, so to the tester class, I don't have to recompile. Okay, that works the exact same way that I had before, so it didn't fix my problem, but at least I have it working. Now what I'm thinking is that I need to alternate. I need to alternate here. Okay, I had paused to think a little bit, And I'm going to try something that might not necessarily be the best way, but in the interest of time, because we are at almost 35 minutes here. And again, it's a little late. I'm going to try this out. If it works, great. And then later on, we can try to see if we can make this better. But what I'm going to do is I'm looking here at the rows, and I'm looking at the even rows, basically 0 and then 2. And those even rows, I know I want to increase my column number. I want column number to go from 0 to 1 to 2. And the odd rows, which would be 1 and 3, I want column to decrease. I want to start call at 2 and then go down 1 and 0. So in this direction. I know I want to do that. And so let me try it out. I'm going to say if the row number, if the remainder when I divide it by 2, so that's the modulus operator, is equal to 0. If that is true, meaning we're in an even row, I'm going to do this right here. I need to indent this. The way I indent is by highlighting this and pressing the tab key. So if I'm in an even row, and I'll make an even row, make a comment there. If I'm in an even row, I want to definitely do this. I want call to start at 0. I want to go until call is less than 3, and I want to populate the row, in this case maybe the 0th row, with scanned of I, and that would be 0, 0, 0, 0, 1, 0, 2. But then after I populate the entire first row, I'm going to populate the entire, or I guess the entire 0th row. I want to populate the entire first row, which is an even row, an odd row. 1 is an odd row. 1 is an odd number. So I can do else if. I don't think I needed the if condition, but for the sake of completeness here, if the remainder when I divide row by 2 is not equal to 0, or you can put the alternative to the remainder when you divide something by 2, you only get 2 possible remainders, 1 or 0. So I could put equals 1. Then I'm going to copy this, and I'm going to paste in here, and I'm going to make a few changes here. I'm going to say I want the column number to start at, there's 3 columns, so I want it to start at 2. That would be num calls minus 1. So num calls is 3, subtract 1, that's 2. I want to check the condition. I want to keep going until call is greater than or equal to 0. The last value that I want for the column is 0. And I want this to stay the same, but instead of adding 1 to column, I'm going to subtract 1 from column. I still want to add 1 to scanned. I think that might be it. I don't know. Let's compile and run. And let's take a look. So the first row, 0.3, oh, it's a touch screen, I forgot about that. 0.3, 0.7, 0.8, that works, and then 0.4, 0.1, 1.4, 1.1, and then 0.2, 0.5, 0.1, and then 1.6, 0.6, 0.9. Perfect. It works. The reason why I don't necessarily think it's the best implementation is because there's a lot of code here that somewhat repeats, like this while loop and this while loop. So I'm not saying it's wrong, I'm just saying maybe it's not necessarily the best way to do it. But for now, that's good. So this is part A. When we get back on the next video, I'll go over part B.